4 presentations in the next hour, 4 presentations on energy and society. I'm Jan Webb. I'm at Edinburgh University, and I also chair or co-chair the Energy Technology Partnership Advisory Board. I'm a social scientist, and along with Kirsten, who was here, I saw Kirsten. Hi, Kirsten. We have been proactively, I hope, developing the energy and society theme, and we have 3 online presenters in the session, so it's going to be an interesting dynamic, and 1 in person, Simon. And Emma Corrin is going to lead us off. Can I remind everyone that it's 10-minute presentation, 5 minutes for Q&A next, and colleague Chris there is going to signal, I hope, loud and clear, when there is 1 minute left for each of the presenters. Okay, so Emma, are you ready to begin?
Yes, I am. Can you hear me okay?
Yes, thank you.
Okay, great. So hello, everyone. My name is Emma Corrin. I'm a marine policy PhD student here at the University of Delaware in the United States, East Coast. And I'm going to be presenting a project titled Regional Community Attitudes Regarding Recognition, Procedural, and Distributive Justice Dimensions of Southern New England Offshore Wind Energy Development. And this is a collaborative project across 3 different universities in the United States: University of Delaware, University of Rhode Island, and the University of Waterloo. Next slide, please. So this is just kind of a broad overview of the entire study. The purpose is that we'd like to characterize community attitudes regarding social justice dimensions of offshore wind energy development. And I have these 3 terms here: recognition, procedural, and distributive justice, that I'll describe a bit in a minute. The reason we're doing this is that offshore wind is growing rapidly off the East Coast United States shores, and this is leading to community concerns from residents who live in close proximities to these projects regarding the decision-making process. So we're focusing our study on 4 states: Massachusetts, Rhode Island, Connecticut, and New York. It's a 2-year study. The first year, we conducted qualitative interviews within these communities. And the second year, which has not occurred yet, is going to be attitudinal surveys and comparative case analysis. And we're focusing our interviews and surveys within 7 tribal communities and 5 settler communities. And the word settler is just the term we use to distinguish communities that are not part of tribal nations. Next slide, please. So today's presentation, we're going to be focusing just on the qualitative settler interviews. We're in the transcription and analysis phase. And so I'll be able to share some preliminary observations today, but not the full results yet. And I also just want to note that the tribal interviews are being conducted separately by Dr. Kelsey Leonard at the University of Waterloo, who's also a member of the Shinnecock Nation. Next slide, please. So to start with some context and theoretical framework. Next. So offshore wind is kind of booming right now off the East Coast of the United States. At least it's in the process of booming. Right now, there's only 1 project that's in full-scale development, which is off of Block Island, Rhode Island. That was the first commercial offshore wind farm that has 5 turbines. But there's a lot of leased and planned projects in this area. It's kind of a good area because there's high wind speeds, high electricity prices. So there's sort of a need for alternative energies. And there are large renewable energy commitments across the states in this region. And one of the first large-scale projects is coming very soon, called Vineyard Wind, just south of Martha's Vineyard in Massachusetts. Next slide. So with such a large energy transition comes some oppositions and opinions from the communities who are living near these projects. This is an image from Cape Wind Project, which was meant to be in Nantucket Sound and faced fierce social opposition. Previous literature has found that community support for these projects is often tied to concerns of fairness, transparency, and inclusivity in decision-making processes. Next. And so that leads to kind of the theoretical framework for this study, which is based on this concept of energy justice, which we're defining as achieving social and economic equity in energy policy production and distribution. And there are these three branches that concern our study that were mentioned in the title of this project: procedural justice, distributive justice, and recognition justice. Next slide, please. So procedural justice is concerned with how stakeholders are included in decision-making processes, or you could say whether they're included. And distributive justice is concerned with whether the benefits and burdens of energy projects are fairly distributed. So for example, are those the people who bear the burdens of these projects, are they also receiving the benefits of these projects? And recognition justice refers to recognition of the people or communities who have been ignored, unfairly represented, or not treated equitably. And you can click next 3 times, just a little animation. And this is just kind of a way of remembering these 3 branches. Procedural justice is concerned with the process and inclusion in the process. Distributive justice is about fairness in the outcome, and recognition justice is kind of about recognition of marginalized communities. Next slide, please. So I'm going to talk about the methodology of the settler interview portion of our study. Next. So we conducted semi-structured interviews within 5 New England communities, each of which are affected or placed nearby some of the up-and-coming offshore wind projects in New England. So these include East Hampton, New York, New London, Connecticut, Narragansett, Rhode Island, New Bedford, Massachusetts, and Martha's Vineyard, Massachusetts. Next slide. And so the community in Rhode Island and New York are the site of a cable landing. So that's where the cable is coming up onto the beach. And in New London, Connecticut, New Bedford, and Martha's Vineyards, in those locations, there's a port facility that's being used either for operations and maintenance or wind farm construction. So we chose these communities because they're being clearly affected by offshore wind development. And we also sought to choose communities that have a representation of socioeconomically and racially diverse demographics, and also contain relevant coastal economies, for example, commercial fishing or tourism. Next slide, please. So we conducted interviews. We aimed to conduct about 5 to 7 interviews per community. In some cases, we got a couple more. We used purposive sampling, and so we specifically aimed to interview fishers, members of port waterfront industries, local government, or community groups or members of marginalized populations. These interviews took about 1 hour. We did both in-person and virtual interviews. And the goal was to ask questions that would reveal participant perceptions and attitudes and experiences with regards to these 3 dimensions of energy justice: recognition, procedural, and distributive. To date, we have conducted 36 interviews. Next slide, please. So the next process is thematic analysis. Right now we're in the phase of transcribing and coding interviews. And next we're going to be doing thematic analysis, which is a process of identifying themes throughout the interviews so that we can conduct an analysis and understand what community perceptions are regarding these 3 types of energy justice. Next slide. So because we haven't finished analysis, what I'm going to do is share some preliminary observations that we've identified based on a subset of interviews that we have coded. So to begin, one preliminary observation we found under the category of recognition justice is that community members felt that as though decision makers were interacting with communities simply to check a box rather than actually to meaningfully engage. So 2 quotes that show this idea. One is an individual who said, "I think they were listening to us just to say that they listened to us." Another example is an individual talking about the developer saying they're still a large corporation. They're not going to involve themselves deeply within the community. They're going to do what they need to do to satisfy whatever requirements they have. Next. An example of an observation we found under procedural justice is the perception that communities had no power or say in decision making. For example, this individual said, the fact that we did not have a seat at the table is a problem. If something's going on in your town, they usually ask the people. You might have a referendum or something. There was nothing, no seat at the table. Next. To give kind of a contrasting perception that also goes under the category of procedural justice, we did have some participants say they felt community members did have the option to participate but chose not to. So in this quote, they say, "I think that there are a number of groups that chose not to participate because they think all of the decisions have been made and that they really will have no influence. I also see that as a misperception, but if you want to have influence, it takes work. It's much easier to jump to conclusions than it is to put in the work." Next slide. And lastly, an example of observation we have of community perceptions of distributive justice is an idea that community benefit agreements are not sufficient compensation. For example, this individual said, "I would love to have seen more community benefits. I think in the grand scheme of things, the for-profit piece of it is questionable for me. You know, I think the federal government probably could have taken this development of offshore wind and done it in a much more efficient and equitable way and provided more benefits to the ratepayers and the communities." Next slide, please. So some next steps of our study, we're going to complete the transcription and coding of interviews, conduct thematic analysis, publish the results, and move on to the quantitative survey. Next slide. And I know I'm running up on time. This is the last slide, just as some contributions of the study. So first of all, the need to address justice has been identified through our current administration. We're currently lacking data on justice dimensions of offshore wind energy. And this study will have important implications for policy and management, drawing attention to diversity in offshore wind development and decision-making, and is expected to strengthen community involvement. And next, I think that's just the thank you slide. So I'd like to thank everyone who has supported, participated, and funded this project.
Right, so very diverse and quite interesting emergent findings there. Does anyone in the room have a question, first of all? Perhaps I can ask one, Emma, which is to say, do you think there are prospects from your research, I know it's early days, but are there prospects of shaping the policy process around justice and inclusion in the decision-making about that pattern of offshore wind development?
Yeah, absolutely. And I think that's kind of one key goal of the research is that if we can talk to communities and try and understand what's your perception of you know, whether you've been included or whether you're receiving these benefits and burdens of offshore wind, we can then share that with the developers or federal, state, and local government officials with the hopes of saying, these are kind of the gaps or these are the areas where communities are perceiving themselves to be left out of the process. So if you can fill that hole and be more inclusive in this manner, then you might see a shift in community perception and in overall justice of inclusion of these communities' needs and interests. So absolutely, I think that's the long-term hope of what will come out of this.
Okay, thank you. Are there questions in the room from anyone? Person back there?
Hi, this is Arun Kumar from University of Dundee. It's more of a clarification than a question. I was wondering, you mentioned that that you're looking at participants who are in opposition to this to the employment of or deployment of these offshore structures, because most of the preliminary observations, it appeared that they were people were against it. So is that the only angle that you approach it, or do you also look at are there parts of community where they are for this and in agreement with what's happening?
Thank you for that. That's a very important question. I appreciate you asking, because no, we were not just talking to people who are necessarily against wind. We tried to get a balanced perspective, because if you only talk to the people who are against, you might not see the things that developers perhaps are doing that have been good and inclusive. And we want to make sure we know what's been done right and what's been done wrong as well. And so in our attempt to identify subjects for these interviews, we would look at everything ranging from newspaper articles to references from other people we know and colleagues and collaborators to try and gain a diversity of perspectives. So talk to individuals who have been very vocally for these projects, some vocally against these projects, or some who kind of maybe sit in the middle and who have a more neutral perspective. So yeah, thanks for clarifying that. There are people who are for these projects, and we did not solely look at those who are against.
Okay, there's Kirsten.
Thank you. I'm waiting for my glamorous assistant to bring a mic. So I'm Kirsten Jenkins from the University of Edinburgh, and I wanted to pick up on the marginalised groups that you mentioned. Do you think the marginalised groups in the context of offshore wind are different from those that are generally marginalised in society? And if so, how did you identify who to engage with?
Yeah, that's an excellent question. And I think the answer is both yes and no. For example, often the fishing community sees themselves as a marginalized community with respect to offshore wind, and that's not necessarily an entire societal designation, but more with the specifics of how they're affected by offshore wind projects. But at the same time, we wanted to make sure we also hear from, for example, people who are socioeconomically disadvantaged or who belong to a racial minority, to hear those perspectives as well. And particularly with the side of our projects that's looking at Indian tribes, the goal is to understand how those communities who have historically been marginalized from general decisions in policy are also heard with this particular issue. So it's a bit of both.
Thank you. Is there a question from our online audience? Sorry, Chris, I'm sending you to look at the iPad here.
Yeah, there is.
We'll take one from then.
So from Lara Santos, she says, really interesting study and thank you for your presentation. Do you plan to engage with technology developers at data generation stage to see how they currently perceive the justice dimensions of offshore wind?
That's a very good question. So in this study, we specifically did not interview developers and people working for wind companies, because the goal of our research was to understand community perceptions, and there are studies out there who have looked at both. You know, how do the developers, how did the technology experts view this problem, how did government officials view this problem, how do communities view this problem? So the focus of our current study was on that community perception, but I do think it's important, absolutely, to maybe as a second phase of the study, or perhaps there's other research out there looking into the people who are developing these projects. What do they know about these concepts of justice?
Okay, thank you. Thank you very much, Emma. I think we need to move on to the next person. Just a final thank you. So our next presenter, also presenting online, is Huma Iqbal. Huma, would you like to introduce your project?
Hello, can you hear me? Hello? Can you hear me?
Yeah, you're a little bit quiet.
Okay. Can you hear me now?
Yes, that's better. Thank you.
Okay. Hello, my name is Huma Iqbal, and I'm a second-year PhD student at University of Edinburgh. I'm here today to present and share my research work with you. The topic of my PhD research is multi-level domestic energy management using second-life battery storage and PV distributed generation, a future perspective for developing countries. Before I start, may I just tell that there are animations in each slide, so just keep going, and I will just tell you and move to the next slide. Is that okay? Okay, I hope many of you have heard the term of second life batteries. I'll start with a brief introduction. What are they, where they come from, and are they real? World is moving towards a green future. EVs are emerging rapidly. Despite of the fast charge and autonomy range, there are still major concerns of electric car manufacturers and users. One of them is high upfront cost of EV due to expensive lithium-ion batteries and the other one is battery aging. Capacity and power loss occurs in EV battery a long time and use. This is why when EV battery state of charge rate is 80%, it is said to be the end of life of a battery for automotive purposes. These batteries are called as second life batteries. There's an ongoing research on these retired batteries, like what should be done with these batteries. Should we discard them, or we recycle them, or can we reuse them? Uh, Recycling these batteries or discarding these batteries will release harmful byproducts in the environment, making the entire idea of green technology useless. So recycling is a very expensive option. Manufacturers and researchers are looking for reuse options. One emerging application of these batteries is for energy storage in domestic microgrids. As due to integration of renewables, there are instabilities in microgrids, and energy storage is considered a suitable solution. The second life batteries end of life can be optimized in a way to obtain same techno-economic benefits that can be obtained from a new battery. Then we can say that these batteries can be a global solution, especially for developing countries, if optimized economically and technically. Next slide, please. The introduction of these batteries in stationary storage applications are gaining popularity, but there are still many challenges for the deployment of this technology. Number one is the lack of specific control and energy management strategies for accurate estimation of remaining useful life and extension in lifetime of second life batteries in reuse applications. There is no final optimized aging models in literature for second life batteries so far. There are many aging models for first life batteries, but they are being deployed for second life. But they're mainly based on assumptions, and the impact of changing aging parameters on techno-economical aspects is not considered over long time periods. There are many business models that are now rapidly being introduced by various automotive companies in collaboration with governments and energy supplying companies, but the focus is on economic benefits rather than factors like aging or effect of inflation and future net metering rates on overall cost of these systems. Next slide, please. So the main objectives of this research are, number one, development of renewable integrated microgrid with real-life data and using second life battery as energy storage. Next one is development of second life battery aging model with aging data from literature and determination of aging parameters. A novel energy storage system is proposed using optimized aging parameters over long time periods. Finally, a techno-economic analysis of the proposed energy storage system will be done, taking electricity marketing, inflation, and net metering rates from a developing country. So if we talk about novelty in this research, I would say that control of aging parameters to extend end of life is not a very hot topic. Like the aging parameters are normally considered constant over a long time period of years. But in this research, these aging parameters will be monitored and controlled using an optimization algorithm. An improved control strategy will be formulated to correctly assess the state of health of battery during online real-time operation. Also, there is no particular research taking into account the perspective of developing countries, hence this scenario will be considered. And last but not the least, in previous techno-economic models, they do not include price inflation over the years. So no generic business model can be established so far. So in this research, this factor will also be considered. Next slide. We talk about the methodology. There are three models that will be developed in this research. First one is battery degradation model using aging data from previous researchers. I am using this data from colleagues' experimental results for my battery aging model. Using that data, aging parameters will be identified and optimized using novel algorithms. Secondly, an energy storage system will be developed using an optimization algorithm. A smart energy storage and management problem will be formulated, and the control of power transfer between PV array, electric vehicle, second life battery, and grid will be done in a way that we can increase the power system stability and we can optimally size the battery system. Finally, a techno-economic model using a forecasting algorithm will be developed and to ensure optimal economic sizing of proposed system, considering new and second life battery changing market prices. This proposed model will also give a sustainable business model for residential consumers in developing countries so that they can replace these new high-cost lithium-ion batteries in stationary applications by second life batteries with the same benefits but at a decreased cost. And in turn, governments will also be motivated to introduce new relief policies for the consumers in developing countries. Next, please. The most important step in this research which is also a deciding factor of future of this emerging technology, is state of health estimation using a suitable battery aging model. Here is a comparison of some conventional and advanced state of health estimation approaches that are present in literature so far. So these include model-based and data-driven approaches. One missing point in both these approaches is consideration of battery first use data, which plays a very important part in determination of battery remaining useful life during second use. Some cloud-connected technologies are now being introduced to keep a track of first use data, but that's just a beginning. Next, please. Some conventional health indicators for state of health estimation are internal resistance rise, capacity fade, and current and voltage measurement. But a recent development in this regard is use of multiple health indicators. In this new proposed method, some classes of health indicators are being identified first, and then a combination of data-driven and model-based approaches are used, use robust estimation and prediction algorithms to classify or select the viable health indicators for particular operating condition. So basically, we can say that these health indicators are identified and classified based on accuracy under specific conditions. So this will lead to more accurate and efficient battery state of health estimation in future. Next, please. So let's talk about some results that I have obtained till now. So I started my work with literature review on electric vehicles, going on to battery equivalent models, aging models, and looking aging parameters. Then I moved to second life batteries, and then how they can be reused in domestic applications. So practically, I have started simulation of my own system using MATLAB Simulink. So there are some models I have simulated. One of them is battery dynamic model. Using this set of equations I took from literature, it was like this. I simulated this model and I concluded that the battery state of health depends on many parameters such as state of charge, current during charge and discharge, depth of discharge, and also temperature, which was not considered in this particular simulation but will be done in the next simulations. The higher these values, the faster degradation occurs. So this model helped me to identify and understand the aging parameters. Next, please. So in the next step, PV battery system was modeled to understand charge-discharge process of a battery. Built-in PV array and battery were used from Simulink. First, I ignored the aging effects here. A boost converter with MPPT is there to control the output of PV array and keep it at a maximum. The battery is connected to same DC bus using a bidirectional converter with the charge controller. So the results I obtained are like when irradiation increases, PV output is increased, battery starts charging, and battery state of charge increases, and the current of battery decreases. Conversely, when it decreases, PV array output decreases, battery voltage and state of charge decreases slightly, and the current increases. So in the next step, next please. I modeled a grid-connected PV system. So this is a 4.8 kilowatt solar array connected utility grid with voltage level and frequency according to developing country Pakistan scenario and a resistive load. Next. The results I obtained here depicted that integration of renewables into distribution system decreases dependency on grid, but due to intermittent nature of renewables, stability of conventional system is compromised. It is not provided with an energy storage and management system. So a battery with good state of health and solar panel operating at its maximum output increase the stability and resilience of power system. So if a second life battery has same state of health, it can replace a new battery in energy storage system. So it would have a same effect on the power system stability and will have an additional benefit of economy like decreased cost. Next. So here is the proposed layout of the system. Next is how the system will look in Simulink. Next. So I'm currently working on mathematical or average models of these blocks because it commonly takes hours to charge a battery from low capacity to full. Hence, using physical models during simulation can prolong the simulation time from hours to days. As we are hoping to see the battery behavior over long time periods, we have to find a way to increase the efficiency of the proposed model. Another hurdle that is faced till now is obtaining practical second life battery data. I've tried to contact many academics working in the same field and also used some industrial contacts, but currently I'm using sample data from literature to get the results. Next.
Can you summarize now, please?
Yeah, this is the last slide. This is the
Okay,
last
good.
slide. Okay, so the future work plan, like the model will be simulated for whole day first using full day radiation data and load profile, and technochemical analysis will be performed using new and second life batteries. Meanwhile, an accurate optimized data health estimator will be developed, and these models will be combined to see battery degradation and remaining useful life for time period of years. So that's it. Any questions?
Okay, thank you very much. Thank you. You covered a lot of ground there in a very intense, short session. Are there any questions in the room for Huma? Perhaps again, I could start off just by asking you, you began your presentation, I think, with this question about hype or reality. And you've shown us a lot of the technical, economic kind of and scenario modeling, but does that address that question of is this really hype or reality? You made reference to second life batteries, perhaps in a developing economy context, but is that your conclusion? Was that pre-made, or is that something that emerges from your modeling?
Thank you. That's a good question, because that's what I'm trying to find out. Because it's being proposed in previous like researchers and in current literature that this can be a solution, but there are no practical implementations or practical development in this regard yet. But I cannot see that there is this practical model or where second life batteries are being deployed and these are the results. There's like, I can say that it's very in a baby phase. So I need to work on it, and I need to find out at the end of my work that whether the assumptions made about the economic stability of this system is true or not.
Okay.
So yes, it's the presupposed phase yet.
Great. Thank you. Questions from anyone in the room? No. Do we have any questions from our colleagues, friends online? No, no. Okay. In that case, I think we'll say thank you very much to Huma.
Thank you.
Again. And we have our third presenter also online, Guanyu Yang. Guanyu, are you ready to introduce your project and your research to us? We can't hear you at the moment. No, still no sound.
How about now? Can you all hear me well?
Yes.
Okay. Hi everyone. I am Guanyu Yang. I am a third-year PhD candidate. Sorry, my speaker has been changing. Okay. I'll start again. So I am a third-year PhD candidate at the Energy Institute, University College London. And today my topic is how are cooling decisions social? And I will present you with the evidence from my survey on office cooling of financial employees in southern China. Next slide, please. So my research is based on the different facts that first, we saw that there is increasing energy use for space cooling in China and of course around the world. And of course, the demand for space cooling is also rising, not only in the global south, but also elsewhere in the world. At the same time, occupant behavior research also showed that the behavior side is very important to understand and to decarbonize energy use in buildings. At the same time, we also have another branch of literature telling us how key this alternatives to air conditioning could be. For example, lighter clothing or personal cooling devices can be to decarbonize the space cooling use. Next slide, please. So my research is basically based on a social psychological approach to social norms. And mostly I'm using the definition of social norms from Cialdini et al. And I would consider social norms to be divided into descriptive and injunctive. And I also see that social norms, it can be very powerful in China, considering the influence of social conformity. And in terms of research gaps, in my area for the occupant behavior research, there has been a lot of emphasis on the physical and the physiological features of the occupant or the building characteristics. For instance, the building indoor or outdoor temperatures, occupants' thermal comfort, etc. But I have seen very limited investigation on the social dimension, and also within this, there has been very limited focus on alternative cooling, which I mentioned just now, includes the use of personal cooling devices and lighter clothing, which will be the focus of my study. Next slide, please. So my survey is an online cross-sectional survey which built on our previous interview study, which is the stage 1 of my PhD, which is right now in press with the journal Energy Research and Social Science. And it's and for this survey, I sampled the financial employees in Guangdong province in China with the help from a Chinese market survey company called Wenzhenxing, and it was conducted between March and April in 2022. And in total, I have 439 valid responses. So far, I'm going to present to you the descriptive statistics and the very exploratory regression analysis based on the data I collected. And you can see on the right-hand side, there are slightly more male participants than female, and a relatively more people chose other financial services. And then the mean age of my sample is 30. Next slide, please. So this is a very interesting graph I meant to show you. So this is based on the question that I asked in the questionnaire about how do you negotiate the environmental control in your office, in your shared offices, or in your meeting rooms in your company. And by environmental control, I mean it can include the use of air conditioning, adjustment of air conditioning, window, or the blinds, the curtains, and you can see that from different strategies. If you look at the management of leaders, management level, management or leaders, you can see the mean actually increase from the office to the meeting rooms, because and we speculate that it will probably be because the leaders will be more present in the meeting rooms compared to in the shared offices, which where the leaders might not be there often, because the leaders might have their own offices. And next slide, please. And here I would like to present three types of data corresponding to the behaviors of interest in this survey. The first is about clothing behavior, which I divided into clothing adjustment and clothing warmth. So far, 81% of the participants reported that they would adjust their clothes when they feel discomfort. So this is a yes or no question. And then for the clothing warmth, we actually built we recoded this variable based on a adjusted or an adapted flow insulation measure based on the ASHRAE and also the ISO standards. So we asked people to take which typical outfit you usually wear in a summer working day, and then they based on the outfit, we develop a 5-point scale measure from very cool to very warm, and then we map. So we transform, we coded the clothing checklist into this clothing warmth. Then because of the time limit, I won't be able to share with you the descriptive of this 5-point scale. And we can see there are still quite a lot of people who would wear warm or very warm clothes in summer offices. And on the right-hand side, we can see there is the use of frequency of use of personal cooling devices. And we divided them into fan-based and seat-based personal cooling devices based on a principal analysis later on. And next slide, please. And moving on to the regression analysis. So for the Model 1 and Model 2 on the use of personal cooling devices, we have, so these two models are the linear regression models. And we can see that the descriptive norm of how the other colleagues are using personal cooling devices are so far the most significant, and they all positively correlate with the use of personal cooling devices. And also for fan cooler use only, though, the injunctive norm of how leaders will look at personal cooling use is also positively related to the use of fan coolers. And meanwhile, we can see that personal image, interestingly, is also is positively related to the seat-based personal cooling, which is very interesting because in terms of personal image, obviously the fan cooling with this air flow, it can mess up your whole personal image. But with the seat-based PCD, it usually would not interfere much with your overall self-presentation, because you can basically just sit there and there's no airflow. And then moving on to the next slide, please. Okay, so here about the clothing behavior. So as I mentioned, I broke it down into
one minute, please.
Okay, clothing adjustment and then clothing warmth. Again, the descriptive norm of suit wearing are both significantly correlated to these behaviors. And then the influence from authority it's also positively related to clothing warmth. And then the use of so if a person is in a single occupant office, then they seem to adjust their clothes more. And for male, interestingly, they tend to wear warmer clothes. And next slide, please. So moving on to the implications, or the initial implications of my study is that I think from the results that I showed you just now, social norms seems to affect cooling strategies via this very specific descriptive norm from colleagues. So if your colleagues are doing something, then it seems very likely that you are also doing something. Like you tend to use more cooling, fan coolers or seat-based cooling, and you also might adjust your clothes more often. And the organization hierarchy, as I have shown you about the difference in negotiating strategies between the shared offices and meeting rooms, and then the injunctive norm signals from leaders, from the influence from authority, etc. They all tend to be significantly and positively correlated to the cooling strategies. And about the visibility of adaptive behaviors, for instance, like what I said just now about the difference in the meeting rooms, between the meeting rooms and then the shared offices, because when you adjust something in the meeting rooms, it might be more visible. And then also in terms of personal image, when it can influence something that can be more salient, can be more visible, then people might refrain from doing something or might tend to do more of this cooling behaviors. And that's it. Thank you.
Okay, thank you. Thank you very much. So for Guan Yu, any questions from our audience in the room first? Yeah.
Sorry, just waiting for the microphone. I was wondering if you could just describe a little bit more the difference between the two types of norms that you describe.
Okay, so you mean descriptive norms and injunctive norms?
Yes, those two things.
Okay, so yeah, sorry, because of time limit, I wasn't able to elaborate on this. So basically, descriptive norms, social norms, mean that something that what the majority of people commonly do. So as is, you know, descriptive. So it's just like you see what the others are normally doing. And then for the injunctive, it means that it has some sort of like disapproval or approval connotation behind this. So you can see something like maybe your leaders or your colleagues might disapprove of something. So this is or approve of something, and that might have if that might be faced with sometimes social sanctions, etc. So I hope I have solved your question.
Okay, thank you. Chris, is there any
yeah, we've got time for one more question from
you have the online ones.
From online, and it's asking, did your reason for choosing to study these norms was it influenced by collective cultures and societies such as China or other places?
Yes, this is part of the reason why I focus more on social norms, because as I said, there is a trend of social conformity in China, and also we tend to try to preserve harmony collectively in our society. And also my whole PhD is trying to use behavioral economics nudges. And within this, social norms also come on top as a potentially very important behavior change tool. So that's why social norm is the focus here.
Okay, thank you. Do we have any other questions? There's nothing online, no? No. Okay, I think we'll move on to our final presentation then with one last thank you to Guan Yu. Thank you very much, and I hope the thesis goes well. So we now have, in person, Simon Vakeva Baird, okay, who also UCL, who is going to tell us about your project there.
And I'm not a floating head, you get the real me. So yes, hi everyone, thanks very much for coming along to this session. It's a big room, it feels like there's not many people here, but I'm sure if we're in the small ones, there'll be a lot more people. So yeah, my project is combining building dynamic simulation with multi-criteria decision-making methods for a participatory design framework for net zero buildings, which I get is a bit of a mouthful. Today I'll be talking to you just about the initial stakeholder engagement side of things. So that has an even longer title for the purpose of this presentation, which is combining consultation surveys with qualitative discussion and quantitative multi-criteria decision-making workshops to engage stakeholders within the design process for healthy net zero whole life carbon buildings. And for the purposes of this presentation, and when I started this project, I got given the title Climate Responsive Building Design, so let's just go with that, and it's a lot easier. So the problem context is looking at whole life carbon of a building is basically looking over the lifespan of a building, which is 60 years. And over that cycle, you have many basically ways that the building emits embodied carbon emissions. So we start with the product stage, so things like the transportation of materials from extracting in the ground to the site, construction stage, the in-use stage, and operation stage. the end-of-life stage of the carbon emissions, and also circular economy. So these are all things that we have to take account of when we're trying to curtail emissions from the built environment sector. And currently, this isn't really done too much in practice, and it's not really looked at too much in research either. So yeah, this is over the 60-year period. Yeah, as I said, research looking into the design of net zero buildings kind of focuses on the operational energy side of things, and it doesn't really consider that whole life carbon scale, which is over 60 years. So as expected, a lot of design research looks at operational carbon and cost and tries to optimize those things, those criteria. And so time intensity and computational and cognitive load associated with optimization and form parameterization aren't really preferable for use in design practice, but they can lend themselves well to research. And the focus on operational energy alone means that sometimes the solutions proposed by this research can have really high life cycle impacts. They can emit really key environmental parameters such as overheating risk, and also neglect social value. The performance under future climate conditions is also not really tested. So with the warming climate, how do these buildings respond to changes in climate, and how does this affect the measures we take to basically make our buildings comfortable? And early engagement with stakeholder groups is crucial to this problem understanding and embedding this value within the design. And as someone pointed out in a previous presentation today, I think in the other energy and society session, or perhaps in this one, that it's kind of seen as a box-ticking exercise in industry quite commonly. So it's trying to change that culture. And a lot of these whole-life carbon assessments, when you're looking at it over the whole life cycle period, is undertaken ex post. So this is done when the building is already there, it exists, the impacts have already occurred essentially, and it's looking back and maybe reflecting, but we're not doing this early enough and then actually preventing these emissions from happening in the first place. So to give a bit more context on the social background of this, so social values in building design kind of relate to the culture, the community, and the collective visions of how we can embed place-based values, which is another theme that was raised earlier, into the building design process. So this can range from things like sourcing local materials, supporting local economies, to incorporating vernacular architectural styles and really reflecting the culture of the area. And this can often lead to additional benefits for carbon and indoor environmental quality performance, as a lot of these materials have been used for decades and centuries in these areas. And then standards and toolkits such as the ones that I've listed above are becoming more and more used and advocated for in industry. So it's about trying to align this with the more technical and complex whole life carbon design of buildings. Another problem, as I mentioned, is the warming climate. So low carbon building designs are really greatly influenced by the climate in which they sit, in which we build. So what works in one climate might not work in another, and we need to understand how these differences affect whole life carbon design and low carbon design. For example, another really key problem that we're going to face is as the climate warms and we start to install more cooling devices in our homes, the embodied cost of that and the embodied cost of then the maintenance cycles that these incur is going to be significant. But if we're not taking awareness of that now, it's going to be too late by the time, like 20, 30 years ago in the future. Yeah, so something to consider. So basically the purpose of this research is to develop a design framework, which I'll be using with different case studies. And it needs to be performance driven, so it should be based on key indicators of performance, not just energy and cost, but also indoor environmental quality and social value. It's argued the value thinking focus is useful for providing a fewer number of high quality ideas in the decision making process. So this is handy because optimization studies in this kind of broad research might not be appropriate. And like I said before, it's really crucial and important to see how our results vary between different climate zones. And so I'll be trying to use some live case studies for this work. It aims to be collaborative in its participation and to evaluate that participation by using a series of mechanisms which I'll embed into the steps of the methodology. And it needs to occur at the concept design stage. So as I mentioned before, it needs to happen early on in the process. Before it's too late. So this is the overall framework of the research. I'm only going to be talking about the dashed section, which is method A today, which is the surveys and workshops. But parallel to this work, I'll be modeling the case study buildings and testing for operational energy, embodied carbon, and environmental performance through building simulation. And at the very end of both of those two stages, then I'll be validating the framework through an evaluation and results synthesis. But for now, let's just focus on method A. And so currently I have 2 case studies which I'm working with. One is in Newcastle-under-Lyme, and it's a flexible commercial space with a temperate climate, and the other one is a school building in Kigali, Rwanda, tropical savanna climate. So obviously, I'm sure we're all well aware there's going to be cultural differences, there's going to be climatic differences, alongside all the differences that I'm going to face myself engaging with these stakeholders. So yeah, they're both new build projects. They both have net zero whole life carbon aspirations, so they really want to bring this carbon down from the projects from the early stage. They have a real strong focus on social and environmental elements of the design, the actual practices that are engaging in these projects. And they have alerted me that there's an accessible and mixed stakeholder group, which is key to this work. So yes, the first is the consultation survey, then a drivers and barriers workshop where we explore values and perceived opportunities and challenges. Then I'll be using an analytic hierarchy process workshop and a cross-case synthesis. So the first of the methods is a survey, and this aims to answer some questions such as how can we tailor the framework's content for each case study and make it applicable to these locations? What are the client and design team's aspirations and expectations of a design framework? So what are they used to in everyday practice, and does this fit into their way of doing things? And then how do we best evaluate the process and results at the end? So yeah, that's just a little graphic to sum that up. So then the workshops that I'll be using in this phase of the work are the drivers and barriers workshops and the multi-criteria decision analysis workshop. There will be a later design refinement exercise, which is more participatory in its nature. And I'll probably skip through this in essence of time. So yeah, the drivers and barriers workshop will first allow respondents to identify the key challenges and opportunities in trying to achieve a net zero, healthy, socially valuable building in their climate. So first it will identify them, then it will categorize them across common themes from research and industry, so technical, environmental, economic and social, and then it will discuss their level of impact and also timing. So adding another level of detail past what is currently practiced in research. And then finally, I might have to go a little bit quickly through this, but essentially multi-criteria decision analysis methods are ways of breaking down complex problems into their component features, and you can allow the assessment of multiple criteria that can be conflicting or varying in their typology. And so I'll be trying to use one of these in the methodology for this work by allowing respondents to basically provide weighting to different criteria and design principles that go into the building's design. So technical would relate to carbon, environmental might relate to indoor environmental quality, and then economic and social a bit more self-explanatory. So allowing stakeholders to actually give me their preference, and this is basically uses a software, and it would look something like this when it's finished. This is just a basic representation of it at the moment. But each design principle might have a value assigned to it, and this could be reflected across different stakeholder groups in terms of how strongly they feel about a different criteria. And then finally, I will collect and tabulate the results using cross-case synthesis. So that firstly involves a data reduction process, then display, and then conclusion drawing between and within both case studies to compare the similarities and differences of the results. So the next steps really are starting the building modeling and simulation runs for both the case studies, trying to actually get more case studies, the better the analysis can be. And then some challenges include, which I've been experiencing recently, which is the volatile nature of live construction projects, trying to reach and utilize multiple stakeholders effectively, the availability of EPD data, which is basically the embodied carbon data that I need from basically extracting something from the ground all the way through to its end of life. How do we source that data and where does it come from? And also obtaining accurate climate data for these places that I'm going to be doing the case studies for. So thank you very much for listening. It was a bit of a whistle stop, but thank you very much.
Thank you very much. Questions for Simon? One and one.
Thanks, Simon. That was great. I'm just wondering, with you saying that you're thinking of doing more case studies, if possible, do you think you try and do a domestic one for domestic buildings? Residential, sorry. So, yeah, I suppose it's a thought as much as a question, just that we've got a lot of trouble in the UK with getting the kind of big five builders to do anything other than what they like doing. So, yeah, that seems quite challenging to get them to, well, yeah, to build a consensus around social value when we've been struggling for the last 15 years to even get any environmental kind of reductions.
Sure, yeah, it's a good point. My first answer to it would be that I think it adds, there's already so many variables that I'm kind of comparing against, but they're completely different, like different climates, different cultures, different project aspirations. And I'm trying to then keep it non-domestic, just to have one thing at least kind of similar. But it is absolutely a possibility, and I feel like it would still make for great analysis. And like you said, if I can engage the stakeholder groups correctly in a domestic sense, then that would be really useful. What I'm saying about there, what I'm thinking about is, so domestic, you'd have potential end users, you'd have people that are living in these homes. For non-domestic, I have engaged estate management teams. So for example, in this case, what are the embodied, so basically if you propose a really high performance building to an estates management team, you're essentially giving it to them for the next 20, 30 years to look after. All the decisions that they make go into the embodied carbon of performance of the building later on when they want to replace things or they want to make things more high tech or less high tech. Then this brings in a whole realm of complexity when you're then looking at end users of buildings because you don't know who's going to be there. You can only hope to get representatives, which is a possibility and is what I might have to do for the Rwanda project, which you saw. I might have to get representatives of, for example, teachers that they're not going to be the teachers that are going to be in this building, but they'll be from a local nearby school, and it'll be fairly hypothetical. So yeah, I've gone on for a bit there, but yeah.
Okay. Okay, yeah, thank you. Can we have one more question? Well, two there, if we have two quick questions.
Thank you. So you have mentioned this needs to start early, and you are talking about low carbon design and how that should start at concept design stage, I think you've mentioned. Can you tell us a bit more about what pragmatic steps should have taken place at that early stage in the process?
In industry or within like this project ideally? Or?
In your project, so you're looking at a framework that is implemented at that concept design stage in order to deliver low carbon buildings, low carbon design. So what are those actual steps that should be implemented that early on into the project?
Okay, so essentially the case studies that I'm going to be looking at is going to be RIBA stage 2 if you're familiar with that or equivalent. And so the data that I'm going to be expecting to be getting is things like floor plans, the uses for different for different rooms, expected occupancies, likely materials and likely energy systems and things like this. The problem that I've kind of identified, and is a little bit anecdotal with working with my industry sponsor, but it's something that all too commonly architectural practices might just apply like a template design. So they get given a brief for a school and they can kind of say like, oh, these are the materials we'll usually use. And so if we can target the embodied carbon at this stage, which is what I'm proposing, doing it a little bit earlier in the design process, we can target these kind of template designs and really design out the embodied carbon before it's too late, because a lot of the time reducing embodied carbon once you're at the stage 3 stage is far too late. So I hope that answers your question. Yeah.
Okay, thank you. And there was one final question from the person behind you there.
Thanks very much, Simon. Really interesting. Henry Jeffrey, Policy and Innovation Group, University of Edinburgh. I'm wondering, and it's a sort of build on from the first question about the residential sector, and I'm interested, do you feel that there's a type of building or a type of like stakeholder that's likely to have like, you know, more influence on the uptake of this building into initial designs than others?
More information available to them and more engaged in the process, do you mean?
Or they're more likely to have influence in the uptake of having this built into the initial designs?
Yes, I do, and that's a serious challenge that I'm trying to ascertain. I think maybe with the consultation survey at the start is to try and kind of gauge how involved are these different stakeholders. So I'll be looking at client teams and design teams and looking at what their knowledge is already of low carbon design, what their aspirations are for a design framework in terms of the actual content of it, and who they expect to, another thing I'm looking at is who they expect to be involved in all of these kind of steps in the methods. So it hopes to reflect their current practice and identify areas of hopefully improvement. Yeah.
Okay, I think that's a very good note on which to end, and to say a final thank you to Simon and to all of our presenters. Very interesting questions coming up, I think, about the social and technical interfaces there, which I think, I suppose speaking as one of the social scientists, think are critical to be addressed if we stand any chance of meeting our climate targets. But I should hand back there to